talking and they want more videos, well, here you go. Now, we're going to talk about function notation. Here we go. A little clicking is just the electronic pencil. Sorry if that's annoying. Function notation. In the past, you have seen something like y equals x plus 3. We would plug a number in for x. We can pick a number at random, let's say x equals 1, and solve. So we would get y equals 1 plus 3, y equals, and then in total 4. Now, what's happened here is that we input the number 1 for the x, and it gave us an output of 4. So x was the input, y was the output. Well, for high schoolers, the way we write function notations or pair an input variable with an output variable is as follows. It looks a little different. We're going to use the notation f of x. Okay, so f of x, you say that f of x. All right, f of x. Say it once yourself. F of x. It's not fx, it's not f times x, it's not fox, it's f of x. And that's the output variable, or the output represents the output of the function. The function can be the same thing, x plus 3. We're just using this new notation out front to represent the output. Why do we like that? Well, because it shows us the thing we're putting into it, an x, the thing we're plugging in the function. We're going to input some number for x, and then we change it right there with the x's. For example, f of 1 equals, wherever I saw an x in the beginning over here, now I plug in 1, equals 1 plus 3. That equals 4. So I plugged in 1 for x, I got an output of 4. Why we like this notation is because it easily shows us what number was plugged into the function that gave us this output. So it quickly shows the pairing of the input and the output. Whereas in this notation, y equals 4, we didn't know what the input was just by looking at this. Okay, and so here we go, I'm going to rewrite it. F of 1 equals 4. Something else we can notice is that if we input an x variable, all right, and we output the y variable, well, this has paired 1 and 4. 1 was an x, 4 was the y. And when we pair two things together, x and y, we can make a coordinate pair. So that we can also represent this relationship as 1, 4. Because this function, f of x, we followed some steps, and it pairs some inputs with a given output. And in this case, when I plug in 1, it pairs 1 with the number 4. Okay, so that's kind of a lot of information, but that's the basic overview for function notation. The function notation is when you have the f of x. You don't even have to worry about all this other stuff. Right now, just know that function notation is f of x. The second thing to note, all right, was that we first saw that y equals x plus 3, and then we saw f of x equals x plus 3. Well, if both these functions equal x plus 3, then what does that mean about the y and the f of x? It means that y and f of x are the same thing. They are interchangeable. So if you see your f of x and you're confused, remember, that's the same thing as your y. That's where your y normally is. They mean the same thing, but the f of x gives us more information because it tells us what variable we are inputting. Okay, so that's a little bit about function notation. Now for the notes. Admittedly, these notes these are not my creation, but we will be using them. So a function rule, it's the first note, is an equation that represents an output value in terms of an input value. You can write a function rule in function notation. So, again, the comparison was, we've seen in the past y equals something like 3x plus 2. This is a new function. But now it becomes, in function notation, f of x equals 3x plus 2. All right, continuing the notes. The independent variable x represents the input of the function. The dependent variable y, or f of x, those are the dependent variables, represent the output of the function. Now, these dependent variables depend on whatever number you input, right? Y, or f of x, depends on what number you input for x. So that's why they are the dependent variable. They depend on the input value. Okay, so some little notes, some things to keep track of. F of x does not mean f times x. We talked about that. F, the letter out front, is the name of the function, and x represents the input. So f of x, the name of this function, is f. We could also do something like, so just pause on if we're looking at these things. The name of a function, we can also use different letters. So g of x, that's just saying g is a function of x, and that helps us differentiate two different functions, f of x, g of x. We could also use function notation when using different letters. So for example, h of t, here it's saying, so h of t, and that's it, saying h is a function of t. The one in parentheses is the independent variable. It's the thing you're plugging into the function. And the h of t, the two things together, represent the output, the dependent variable. So again, any pairing of letters is fine, as long as we understand that the one in parentheses is the input, and the whole thing represents the output. Okay, that is all reiterated right here in our function machine. So, our function machine depiction. I'll use the rainbow because it's magical what happens here. So we've already discussed the name of the function is the f, the letter in front. The x, the independent variable, tells us what to plug into the function. Overall, it's the output. And this thing here, this is the function rule. This tells us what to do with an input, right? So if we input, okay, maybe we switch back. If we input the value of 1, I'd write f of 1. It means input a 1. And if I follow the function rule, what do I do with that 1? Well, I multiply it times 3, and then I add it to 4. So we input 1 and we output 7. All right, so just like this, we take a 1 right here. Actually, I'll use the magic. Take a 1, and then it goes into the function, and it computes and does its calculations, and it comes out as a 7. All right, so that's what happens with the function machine. It goes in, the function does its operations on it, and it comes out as a different number. All right, let's do these examples together. You might wish to pause the video and try them on your own. But what number 1 is it telling us? Here we go. It says, if f of x equals 2x minus 7, what is f of 2? So it wants to know the function value at 2. Well, the 2 is replacing where we normally see the x. So that means we are inputting 2. We're inputting a specific number 2 into our function. So then we go back to our function rule, We're going to change the x. Wherever I see an x, I replace it with a 2. That's all it wants us to do. Whatever number's here, wherever I saw an x, I replace it with a 2. And do the calculations. 4 minus 7 equals -3. So when I input 2, I get an output of -3 for the function in question 1. All right, so the number here just tells us what we input into our original function. Now let's do it as in number 2. We're going to use the graph to find f of -1 and f of 2. So we're going to be finding 2 different pieces of information. Let's start with f of -1. Well, again, we go to where the -1 is on the x. No, sorry. The -1 is the x value. All right, so we're plugging in -1 into our function. This time we don't have a function rule written out like in the previous one, but it's telling us that x is -1. So what we can do is go over to our graph here and then find on the graph an x of -1. So I go to the left one. It's right here, -1. There you go. Easier color. And then what I do is I look at -1. What's the output at -1? Well, it's up here at a y value of 1. So f of -1 equals 1. Now I'm going to do f of 2. So this time what I do is it's telling me I'm inputting 2 in the function. My x is 2. So I go to 2 on the x-axis over 1, 2. And then where's the output? The output happens to be right on level with the y-axis, and that would be a value of 0. So f of 2 equals 0. So all we have to do for these ones is go to the whatever x value is indicated on the x-axis and then figure out what the output is. All right. Number 3, you should be able to figure out on your own, but I'll give you the final answer. G of 2 equals 4. So when you input that 2 for x, you're going to get an output of 4 if you do the math correct. Let's look at number 7. This one's a bit different from everything else we've talked about. So you're going to want to pay attention here. It says our function f of x is equal to 8 minus 4x. When does f of x equal 12? When does the function have an output of 12? Well, normally we have an input that tells us what the output is, but this time they'd give us the output and want us to tell them what the input is. So here's how it works. We go ahead and we notice that it says here f of x equals 8 minus 4x, and we have an f of x right here, so I can replace that f of x with what the function equals. We get 8 minus 4x equals 12. Okay. So we're setting the function equal to 12, and then we solve for x, and that will tell us what input value gives us an output of 12. So subtract 8 to both sides. -4x equals 4, divided by -4. X equals -1. So if I input, and I can check it off to the side, but if I input -1 into my function, we will see that in fact the output is 12, which is what we started with. So that's good. That means we did it correctly. All right. We did it correctly. So this technique, instead of plugging in a number for x, we set our function equal to the number we have and then solve for the x. So we're kind of working backwards. We're taking the output and finding the input. All right, real quick, I'm going to go over the answers to these questions. You can pause the video, try it on your own, and then compare. So f of -4 is 6, f of 7 is 0, f of 13 is -55. I'm just going to the table, and then I look down at what the answer is. F of 8, go to 8, look down, it's -13. Here we go, the graphing ones. These seem to trip people up. F of -2. Well, I go to where -2 is on the x-axis, and then I count up until or I go and find what the output is for the graph. The output's up here at 4. So I just write a 4 on the line. F of -1, go over to -1, count up, until I find where it intersects. This one's kind of halfway in between, so 3.5. F of 0 is perfectly at 3. And the function at 2, I go over 1, 2, and the function, the output's down here this time at -1. All right, thanks for watching. Give it a like and subscribe.